Hi, Core Chemistry. Mrs. KJ here, going over part 2 of lesson 1.04, gas review. So we're moving on to problem set 53, which is Boyle's law. Use Boyle's law to solve problems involving changes in pressure and volume of gases. Boyle's law states that the pressure and volume of a gas are inversely proportional, meaning when one goes up, the other goes down, when, of course, the temperature and the amount of gas are kept constant. Boyle's law describes the relationship between pressure, capital P, and volume, capital V, for a fixed amount of gas at a fixed temperature. According to Boyle's law, if you increase the pressure of a gas, its volume decreases. If you decrease pressure, volume increases. One way to express the relationship mathematically is with the equation PV equals K, in which K is a constant. However, a more commonly used equation is P1V1 equals P2V2. In this equation, P1 and V1 represent the pressure and volume of the gas before the change, and P2, V2 represent the pressure and volume of a gas after a change. Sometimes you'll actually see like PI, VI for like initial, or PO, VO for original, and then PF, VF for final. This equation describes the effects of changing the pressure or volume of a gas. Example 1. Actually, let's read this first. Remember, Boyle's law relates the pressure and volume of a gas at a fixed temperature. Boyle's law applies only to systems in which neither the amount of gas nor the temperature is changing. Although Boyle's law describes the behavior of many gases under common conditions, it does not accurately predict the behavior of all gases under all conditions. Basically, there are some exceptions, which we'll talk about later. Describe the effects of a change in pressure. A 2.0 liter balloon has a pressure of 2 atm. When the balloon is compressed or squeezed, the pressure increases to 5.0 atm. What is the volume of the compressed balloon? First thing you should do, make a list of what you know. I would like you to hit pause and get your answer. And then we can algebraically rearrange our equation, plug in your numbers. We can check and say, yep, the ATMs cancel and I'm left with liters. Liters is my unit for volume. That's good. My answer is 0.8. All right, what happened to my pressure? My pressure went up, so my volume should go down. Did it go down? Yeah. So make sure it makes sense. That's how you can check your own answers. Do you have the right unit because the other one's canceled? And if pressure goes up, volume should go down. Let's look at the next one. A 1.0 sample of nitrogen gas is at a pressure of 1 atm. What will the pressure of the gas be if the volume is reduced to 0.25? So again, hit pause. I know it all comes up at once, but after you do, think about it. My volume did what? My volume decreased, so my pressure should increase. I plug everything in, my liters cancel off. I'm left with the unit I want for pressure, ATM, and my answer is bigger. So my pressure went up because my volume went down. Woohoo! All right. And then for this one, it says to just go ahead and do problem 4. All right, you can do the other ones, obviously, that's why they're here, but in the lesson it says to do number 4. So if a 3.0 liter container holds a sample of oxygen gas at 1.5 atm pressure, if the pressure increases to 2.0 atm and the temperature remains the same, what is the new volume? So write down everything you know. And then I would say too, all right, my pressure increased, so my volume's going to decrease, which means my final answer should be what? Less than 3. So then if we look at our answer key, we are given the information, which we should have set up here. It's problem 4. Use your algebra skills to rearrange, and our answer is 2.3 liters. All right, I'm just going to scroll down so that if you want to do the next one, you can. Hit pause and get all your information. And then I am also going to back up one page so that if you want to do problems 1, 2, and 3, which are here. Oh, why did you do that? There you go. You go ahead and hit pause. You can do all of them if you'd like to, and then I'll put the answers up in 3, 2, 1, 0. So again, hit pause. Here's number 1. Hit pause. There's number 2. And you can hit pause. There's question number 3. All right, let's review Charles' law. Charles' law states that the volume and temperature of a gas are directly proportional when pressure and the amount of gas are kept constant. So use Charles' law to solve problems involving changes in temperature and volume of gases. Charles' law describes the relationship between temperature, capital T, and volume, capital V, for a fixed amount of gas at a fixed pressure. Because we can only change two things because we want to see what the overall effect is. In real life, they all change, and we'll be doing problems with that coming up. Woohoo! According to Charles' law, if you increase the temperature of the gas, its volume increases. If you decrease the temperature of the gas, the volume decreases. One way to express this relationship mathematically is with the equation V equals kT, in which K is the constant. However, we're going to use V1 over T1 equals V2 over T2. So V1 and T1 being our original or before the change, V2, T2 being after the change. This equation describes the effects of changing the temperature or volume of a gas. When using Charles' law equation, you should always convert temperatures to Kelvin. How? Take your degrees Celsius and add 273. All right, a sealed 1.0 liter plastic soda container contains air at 340 Kelvin. The temperature of the air decreases to 260 Kelvin. Assuming the pressure inside the bottle does not change, what is the final volume of the bottle and the gas? So go ahead, hit pause, get all your information, and let's think it through. My temperature, what? My temperature goes down, so my volume is going to also go down. So your final answer should be less than 1.0. So algebraically rearrange it, plug in all your answers. The K's cancel off. One way to tell you're doing it correctly. So you ended up with liters, and our answer is 0.76, which is smaller than 1. Woohoo! Remember Charles' law. Charles' law relates the temperature and volume of a gas at a fixed pressure. Charles' law applies only to systems in which neither the pressure nor the amount of gas is changing. Although Charles' law describes the behavior of many gases under conditions, it does not accurately predict the behavior of all gases under all conditions. So again, there are exceptions. All right, here's our next problem. A sample of a gas at 225 Kelvin is allowed to expand at pressure from 1.5 liters to 5.0 liters. What's the final temperature of the gas? So hit pause, do the whole equation. Tip when solving gas problems, always convert temperatures to Kelvin, which they did. Using Kelvin ensures there are no negative numbers in the equation. It also ensures that the ratios between the different temperatures are correct. So our volume went up, so our temperature should go up. So our answer should be greater than 225 K, and it is. It's 750 K. All right. So for these, again, you can do all the problems. They want us to do problem 4 specifically, so let's do that one. The temperature of a gas rose from 250 to 350 K. At 350 K, the volume of the gas was 3.0 liters. If the pressure did not change, what was the initial volume of the gas? So write it all out, hit pause. Let's think about it. Our temperature went up, but this is our final volume, right? So we're looking for the original volume. So the original volume should be more than or less than 3. The original volume should be less than 3 because it went up to 3. So let's check our answers. And you should have had everything listed out and put in. Hit pause as you need it. And your final answer should have been 2.1 liters, which was actually our original volume. So if you did number 5, you can check your answer for that. I will back up and you can check your answers for number 1 and 2. And number 3, if you decided to do them. And Gay-Lussac's law. Use Gay-Lussac's law to solve problems involving changes in pressure and temperature of gases. Gay-Lussac's law states that the pressure and temperature of a gas are directly proportional when volume and the amount of gas are kept constant. Gay-Lussac's law describes the relationship between temperature, capital T, and pressure, capital P, for a fixed amount of gas at a fixed volume. According to Gay-Lussac's law, you can increase the temperature of the gas, its pressure increases. If you decrease the temperature of a gas, the pressure decreases. This relationship is P equals KT, where K is the constant, or of course, our original party, equals our final party. In this equation, T and P are original temperature and pressure, and of course T2 and P2 are original pressure and temperature. All right, I don't like that they didn't remind us why. Temperature means what's happening to the molecules. They're moving faster. So if there's moving faster, what's going to happen to the collisions? There's going to be more of them. That's why increasing the temperature increases the pressure. Gay-Lussac's law, as we just said, it relates temperature and pressure of a gas at a fixed volume. Gay-Lussac's law applies only to systems to which neither the volume or the amount of gas is changing. And then this one's going to say, although it describes most gases, it does not describe all at all conditions. Describe the effects of a change in temperature. The air inside a sealed, rigid container has a temperature of 295 Kelvin. At this temperature, the pressure in the container is 1.0 atmospheres. What is the pressure inside the container if it is heated to 373? Write down everything you know, hit pause, do it yourself, and my temperature increased, so my pressure should increase as well. And it does, from 1.0 to 1.3. And here we have our next equation. At 325 Kelvin, the pressure inside a gas-filled container is 2.3 atm. If the pressure inside the container decreases to 0.75 atm, but the volume of the container does not change, what's the final temperature of the gas? Plug everything in, get your number. And so my pressure went down, so my temperature should go down, which it did. All right, and so here's the problem set. Go ahead and hit pause and do all the ones you want to. We are actually going to look at number 3 for this one. A gas has a pressure of 2.0 atm. If the temperature decreases from 250 to 125 and the volume remains constant, what will be the pressure? Write down everything you know. My temperature decreases, so my pressure should also be decreasing. And here is what we get for number 3. And I'm going to go ahead and show you the answers for number 2 and number 1. So again, hit pause as you need it. And then I'll put up 4 and 5 as well. So again, do the ones that you need to. If you go into the lesson, there are some extra links. If you want to play around with those, you can. Otherwise, that should be it. Good luck. Let me know when you need help.